Okay, so now we're going to construct a triangle again, and again I want it to be a scalene triangle here. So it's on purpose not meant to be an equilateral triangle. Those, you can do a lot of things and get away with them when they're equilateral that don't work all the time for the other ones. So now what we're going to do is we're going to draw a circumscribed. We're going to circumscribe this triangle. So that is to find the circle that has where this triangle will be inscribed in it. So in other words, the circle that has these three vertices in it. Now you're going to probably be tempted to use circle through 3 points tool, and trust me, I like that too, but I'm not going to accept that for an answer right now because there's also a very simple and logical method for doing this that actually I know that the Common Core wants you to learn. So it's really not that hard, but we're going to think about it. Now what I need to do is I need to find the points that are equidistant from these vertices, right? So now let's just look at side A. How would I find the points that are equidistant to the end points of side A? Now I talk about it that way on purpose. I'm using that language on purpose because we have endpoints of a side or endpoints of a segment. And you've done this many times by now already. The points that are equidistant from the endpoints of a segment are on its perpendicular bisector. So if we construct the perpendicular bisector, we know every point here is going to be equidistant from these endpoints. Okay? Now, we just need to do that to the other sides, and we find the point where they concur, or the point of concurrence, right? And let's get that. With our point of concurrence here is going to be the point that is equidistant from A and B, also equidistant from A and C, and also equidistant from C and B. And this point here is called not the incenter, it's called the circumcenter. The circumcenter. And now we actually have a very simple job because we already know the radius. If we've got the center, the radius is going to be to any of the three vertices because it's going to be equidistant from all 3 points. So that's really all you have to do. If we take off these lines that we did to construct it, okay, and we can even take away point D if we want or leave it there. But I want you to watch what happens as we manipulate our triangle and change it. Notice that it doesn't really matter. We've used the proper technique, and therefore, regardless of which triangle we want, it's going to remain inscribed. So let's record. What was that technique that we used? Well, let's write out the steps. Here we go. First, we found the points that were equidistant from the vertices. Those are the perpendicular bisector of each side. Second, we found the point of concurrence of the perpendicular bisectors of each side, and that was called the circumcenter. Third, we drew a circle with the center at the circumcenter and the radius to any of the 3 vertices. And that is all you have to do. Follow those 3 steps and you can circumscribe any triangle. Okay?